So now we're going to get into the strategy for adding polynomials. So we're going to start to see some parentheses and stuff. But remember, parentheses are a grouping symbol mostly, and sometimes they are used for multiplication. So if I look at this, in this case here, these parentheses just serve as a grouping symbol because there's a big old plus sign here. So what this is saying is I have the binomial 3x squared minus 2x. I'm adding to that another binomial 7x squared plus 5x. So since we're adding here, the easiest way to do this is simply drop the parentheses. So the parentheses are just identifying the two binomials. And since we're adding, like I said, we're just going to drop the parentheses. So this just turns into 3x squared minus 2x plus then the 7x squared plus this 5x. So again, I'm going to be using the circle method here. Lost my colors here, so we'll go ahead and we'll circle that in orange, orange, that, and that. That's my four terms, but I'm going to back up here. You know, since there's so many terms, a lot of times, oops, lost that altogether. So since I did that, we'll just turn back to this color. So 3x squared minus 2x plus then the 7x squared plus this 5x. When there's a lot of terms, it's a good idea to slow play the circle method. So instead of circling everything, I'm just going to circle the 3x squared to start with. And what it goes with is the positive 7x squared. And since those are like terms, we now can bring down our 10x squared. Now I'm coming to the negative 2x. Again, you don't have to use circles. You can use boxes or rectangles as well. There's the negative 2x, and then there's this positive 5x. So since those are like terms, we add those coefficients, negative 2 plus 5, and we get, excuse me, we get a positive 3. So that's going to be, oops, let's get back to the color there. So it's going to be a positive 3x. And since those aren't like terms, that stays as our answer. So remember, you can only combine like terms. Unlike terms just have to stay in the problem. So if I look at this example, notice how we now have this polynomial and we're adding it to this polynomial, or you could call these trinomials. And since we're adding, the strategy is actually just to drop the parentheses. So I have this negative 7x to the third plus this 5x squared and this minus 4. And we're adding to that this negative 2x to the third. And we're going to subtract 6x squared and this minus 5. So as we move through this problem, we're now ready to use our circle method. So again, we can kind of slow play this. It looks like I wrote this down wrong here. Let me fix that. That should be actually a 3. So that looks horrible. Let me use an eraser around here. Let's see if I can get that to erase right there. All right. Let's put that back into, make that a 3. Now I think we're ready to use the circle method. So we have this negative 7x to the third, and we have this plus negative 2x to the third. Notice how we really don't need both those signs. That really just means a negative 2x to the third. I could have dropped that plus sign. So I have a like terms there. So negative 7 and a negative 2 would give me then that negative 9. So that's negative 9x to the third. And then if we look at this next pair, we have this positive 5x squared, and we have this negative 6x squared. Since those are also like terms, we want to put those together, and That's going to give me a negative 1x, or again, we drop the 1 and just call that negative x squared. And then lastly, we have this negative 4. And if you want, you can maybe try to draw like a triangle. You like different shapes or not. Triangles are pretty hard to do. So I have a negative 4 and a negative 5. Negative 4 and a negative 5, that would be a negative 9. So when I add those together, I would end up with that as my answer. So the answer is actually just going to be a trinomial, since those terms are not like. So now we're getting into the strategy of subtracting polynomials. This gets to be a little tricky. So the way I do this is I deal with the subtraction first. So again, it's all about making these parentheses go away. And to make these parentheses go away, we're going to remove the parentheses. But the way we do this, the subtraction we're going to deal with first. So what we're going to do is circle the polynomials. The subtraction sign must go inside the second circle. Let's do that and see where that takes us. So we're going to circle these two polynomials. So this is going to be this one here. And then this is the other one. Whoa, that really got out of my hand. All right, that's not too bad. So we got those. And what we do, though, is once we circle the polynomials, we want to then change the signs of the second polynomial. And then we're going to bring down the first polynomial. And then we're going to use the circle method. So the way we actually approach this is we actually deal with the subtraction part first. And remember, when there's a dash in front of the parentheses, it means to take the opposite of what's in the parentheses. So everything inside the parentheses is going to switch signs. They're going to change signs. So that 6x squared is going to turn into a negative 6x squared. That negative 2x is going to turn into a positive 2x. And that 3 is going to turn into a negative 3. And then we can go ahead and just bring down the first polynomial. So negative 4x squared minus this 5x, and then plus this 2. So now we're ready to use the circle method on that. So we have this negative 4x squared, and we do have a negative 6x squared. Notice again, as we do more and more of these, it's always a good idea to make sure you're working with the highest degrees on down to the lowest degrees. So since 2 is the highest degree, that's really who I should be picking on first. And so that does give me then this negative 10x squared. So then my attention turns into the negative 5x and the 2x would be my next pair. So that negative 5x and that 2x. If I'm using circles, it's not a bad idea to say, hey, I'm done with you. I'm done with you. So now you can kind of say, okay, now I'm moving on to negative 5x and 2x. So that's going to give me then this, sorry about that. Let's just make that a negative 3x. And then we move into the, these are kind of done now. I have this plus 2 and this negative 3, which is going to give me then a negative 1. So that would be my answer. My answer ends up being just another polynomial. And notice how the degrees are counting down. We do want that. So now we know that the degree of the polynomial is a 2. The leading coefficient is a negative 10, and the constant would have been a negative 1. So it's important to be able to identify those things, and organization helps us see that more easily. So as I move into this next example, so we now see another subtraction problem. And again, as I said, when it's a subtraction problem, it's a good idea to just, let's get that. So we can put this in a circle, and we can put this in a circle. What this has really done for me, it's really focusing on, hey, there's that negative in front of the parentheses. So that's what we really want to deal with versus the subtraction part. So it's no longer a subtraction symbol. It now turns into an opposite symbol. And since it's an opposite symbol, that just tells me to change the signs of everything inside the parentheses. So 3x to the fourth turns into a negative 3x to the fourth. That positive x cubed turns into a negative x cubed. And then the negative 1 turns into a positive 1. Once I do that, the first polynomial slides down right in front of it. So 5x to the fourth plus 6x squared minus 1. Okay. So it looks pretty good. Now, as we do this, since there's more and more terms, we need to really start to pay more close attention to the exponents as well. So since the 4s are the biggest exponents, I need to put the 5x to the fourth with the negative 3x to the fourth. And when we do that, we see that we have then 2x to the fourth. From there, we can focus on, actually, the x to the third is our next biggest exponent. So we would be zeroing in on him. So this guy and this guy is out of the way. Notice that there's not another term that has a power 3 in it. So he's kind of going solo. So since he doesn't have any like terms, he just drops down into the answer. And then we're looking for, after the 3 would be then the 1 with the 2. So since there's not another term with a 2 in it, he would just drop down as plus 6x squared. So we're kind of now done with him. So now all we're left with is a negative 1 and this positive 1. So negative 1 and a positive 1 just turns into a 0, and so we don't have to bring that down. So that becomes our answer, 2x to the fourth